So, right. So here are the governing equations. This is the shallow water equation. But it's something missing in this equation. It's the viscosity effect. It's actually lateral uh, momentum diffusion, lateral friction that's missing. So what we do is we actually just add additional forces to our equation. And they're shown here. This is how they look like. This is lateral friction or lateral diffusion of momentum. And essentially there are the second derivative. Second derivative, well, this is what it means, these expressions. This is the gradient of this term here in the middle. It's the water depth times the gradient of u in the x direction. So this is essentially a second derivative terms, and you learned that this. Okay, and this looks a little bit more complex here because we have a layer model which has where the layer can actually change. The layer thickness can change from one grid to another. And this is why the h which is in here appears a little bit more. However, the parameter that controls this effect is called AH here in both equations. They're essentially two equations because you have two velocity components, but the AH is a parameter. It is a so-called viscosity. This is a viscosity. It's a parameter that controls these effects, these diffusion effects. If you set it to 0, diffusion disappears altogether. But anyway, all right. So let's have a look of some additional features. So how do you now formulate friction? Okay, because there's different ways of how to do that.